All right, welcome back. So today marks episode number 4 of the Let's Write an ECS mini-series. If you didn't catch the last one where we did the system manager, then I'll link it as always above and you can go and check that out and then come back here. Last time we pretty much completed everything that we need for a functioning ECS and we used it and I kind of demonstrated how it worked. But the design didn't really leave much for the developer in regards to, it was a bit clunky. It is a bit clunky to use. So that's what we're going to focus on today. Cleaning up the code, making it nicer to use, and that's it. So let's do it. All right. So let's go back to what we did last time. Here's our example where we effectively have all of the components of an ECS and components. And last time we made the system manager where we create a system manager, takes a reference to the component manager, then we create a animal system and we register the kind of signature required for that system by setting components, and then we inform the system manager of an entity and its signature, and then we get the animal system, we update the animal system which prints that animal, and then we destroy the entity, and then we do another update to prove that it works. So let's just quickly show that's working. So yes, you can see here the animal system kind of has entities and then iterates over the entities, and we get the lovely feet, head, face size, and then we delete the entity and we then get no entities for this system. Perfect. Exactly what we want. But again, this is clunky. Like, we don't want to have to tell the system manager about entities. We just want to be able to add components to entities and then the system manager be automatically informed. So first of all, we're going to start off with just controlling the actual ECS itself, right? So I want to be able to instantiate the ECS a little bit nicer, and by doing that I'm just going to have something that is called the ECS Controller, and all this will do is it will just be responsible for kind of managing entity, component, and the system manager. We'll have public and private. So let's just write quick, as we do, responsibilities. 1, responsible for owning entity, components, and system manager. 2, should be the only place where you can create entities. 3, only place should be the only place where you can register components. And lastly, should be the only place where you can register systems. And I suppose also should be the only place where you can get systems. And we don't want to get the components necessarily, because I think we're going to get that out of the wrapper, entity wrapper later. So we've written our responsibilities. Now let's just write a quick constructor. Now remember I said this is just going to basically hold. Oh my, what's going on? Sorry. Right, yes. So you remember I said this is basically just going to hold all of the managers so that you can instantiate an ECS controller and then do everything from that, rather than dipping in and out of these different managers. So we are going to do this. That is not happy. Probably because... Okay, so, and then we're just going to follow the same pattern. So we're going to make an entity manager. We're going to make a component manager. And we're going to make a system manager. Like this. And then we're just going to component manager. Unique. Component manager. System manager. Unique. System manager. And then we also, remember, we need the component manager to instantiate the system manager. So here, perfect. Now we have an ECS controller. It's responsible for owning these. The reason why I'm going to put these as unit pointers, by the way, is because there's a chance that they could get quite big, and I don't want them to be on the stack if that's the case. So for now, put on the heap. I mean, like the entity manager isn't going to, and the system manager probably isn't going to, but the component manager could. So for now, we're just going to do this. All right. So I said the next one, number 2, we should be able to make entities, and let's just make a placeholder class for now called entity, which will be our wrapper for later on, and it'll make a bit more sense later. So we're going to create a function called create entity, and all this is really going to do is just call out to the respective managers. Entity ID equals entity manager dot create entity. Then if entity ID dot bad, return entity ID dot error. And then that's fine. If not, then we're going to return an entity like that. But this will be constructed properly later, and we will fill that out in a bit. So we can create an entity. Let's just put a comment there. Fix me later. Okay, so the next thing we said should be able to register components. So we need to obviously let's put a little nice no discard on this as well, because component type register component, then component manager, register component, component type, like this. Very easy. So now we can register components. Next, we'll do the same thing. I'm not going to copy it. Let's type it. Type name, system type. Again, no discard. I don't want people to discard their kind of IDs, because that would be pointless. Register system. Remember, for this one, we need to have variadic arguments. So system signature. I think it's signature, and then args, and then return system manager, register system type, signature. Perfect. So now we've done 1, 2, 3, 4, and then we need to get systems out. And that again will be another a template. system type. I mean, I'm not going to no discard that because I just don't think we need to. What am I typing? System type, get system ID, system type, system ID, return system manager, get system ID. Perfect. And then I suppose for fun, let's get the entity count. Get entity count and return entity. What was it called? Entity count. Okay, perfect. So here we can do everything we wanted to do before. So we can register components, we can register systems, we can get the system, and perfect. That's what we wanted to do. Now, let's this entity kind of class now will make things a lot nicer because this is where all of the stuff that you kind of had to do manually will be done for you. For example, when you add a component, the entity wrapper will go to the system manager and tell it that the component is updated, and therefore it will all be done for you. You don't have to go and remember all of that stuff. So let's just write some kind of notes about this class. So one is purely a wrapper, right? Two, it holds no state other than the entity ID. And it should update all necessary managers when required. Okay, perfect. So I suppose it's purely a wrapper and it holds no state other than the entity ID. And if we're returning an entity here, then we really should probably construct the entity class with the entity ID, right? So entity ID. And another thought actually is I don't want anybody to ever, other than the ECS controller, construct. Let's just declare that. Actually, I think, can we do it like this? End class? Yes, we can. I don't want any I don't want anybody to be able to instantiate an entity themselves. I only want the ECS controller to be able to instantiate it. So let's make a private constructor and we'll friend the ECS controller, and therefore it can call these functions on it effectively. So the entity ID, like, that's just required. We need to know the ID that this specific entity wrapper owns. And then we also, because we're going to be using this kind of wrapper to speak with all the managers, we need a pointer to every other manager, right? So let's just write that out. System manager, component manager, and entity manager. System manager. Bear with me, just gonna fill these out. component manager, entity manager, entity manager. Okay, cool. So now we can, I suppose we'll construct this with this system manager dot get component manager dot get and entity manager dot get. Okay, perfect. So what's happening here? We're going to create an entity, and when we create an entity, that entity now is effectively going to take the entity ID. It's going to own that entity ID, and it's also going to take a handle to all of the different managers. And therefore, what's this complaining about? That's fine. Therefore, we can start exposing some public functions. So, what do we want to do? We basically, what do we want to do with this class? We want to be able to add components directly to the entity, and we want to be able to remove components directly from the entity. What else do we want to do? We want to be able to get a component, basically. Get component of entity. That way, when we're kind of like iterating over entities, we can kind of just get the component back out, and we don't have to do any of the faffing around of having that entity ID effectively when we're iterating over it in the systems. So let's do the first thing. Let's do the component, adding a component. Component type. What are we going to do? Error add component. Let's do this. Component type, component, and then component ID, component type, component ID. So I think that's everything that we need, right? Yeah, and let's just add it again. I'm gonna add a no discard because we're returning an error here depending on what happens. And so first of all, what are we doing? Add this entity to component manager. So component manager, and we're just going to do what we did before effectively, but we know our ID and we know the component ID, and this is the component we want to add. Let's follow the same API. Okay, and then so if error.good, basically. Yeah, that's right, you see. So if error.good, then what do we need to do now? Basically, we've added a component. We need to update the system manager that this component's signature has changed. So to update the system manager, we need to basically get the existing signature of this entity, update that signature, and then inform the system manager that the signature has changed. So we don't currently have a way of getting the current signature out of the system manager. Entity signature. Let's call it system signature. All right, so we need to implement this get entity system signature function. And the reason for that is because we need to get the system signature first. We need to then update the system signature for that entity. and then inform the system manager that that entity's kind of signature has changed itself. So we're going to do that. Let's do that here. System signature, get entity system signature, entity ID, like this. And then we need a way of storing that. So let's just make an unordered map. Entity ID, system signature, entity signature map. And then every time we kind of inform the ECS or the system manager that an entity signature has changed, we can just effectively enter into that map, right? And that way we can store all the signatures for every entity that's been created. And then we just need to unordered, sorry. Then all we need to do is just return that ID. And effectively, if this ID doesn't have an entry in this map, then this is fine. This operator will just create a default system signature and return it, which is great. No problem. Okay, so we've got the system signature out. We then need to update the system signature with this new component ID, like that. And then we need to inform the system manager that the signature for this entity ID has changed. Like this, current signature. And I think that should be fine, right? So now we're just doing everything that we kind of wanted to do, everything that we did before in our example, right? So you can see here, entity 4. Sorry, get component, add component here. So we create the entity, and then we have to go to the component manager and say, hey, for this entity, add this and this ID, add this component. But now, and then you have to go to the system manager and you have to say, okay, entity 4 has this system signature. Please update, and then it will update all the systems. But now we can just have our entity wrapper and we can say add the component, and what it will do is it will add the component to the component manager. And then if that's all good, it will go to the system manager, get the current signature, set the component for that signature, and then update all the systems with the signature change to see if they should track it, which is perfect. And now we're effectively going to do the same thing, but for remove. Remove component. We don't need the actual component. We just need the component ID. Remove component. Let's get rid of that. Remove component. Like that. What are we doing here? And then instead of setting, we just reset. So we basically say get the current signature for this entity, reset that component ID because we no longer have that component anymore, and then update the systems to see if they still want to track this entity or not. And then finally, what did we say? Add component, remove component, get component. Type name, component type. May discard component name, component type. Get component. Component ID, component type. Return component manager, get component ID. And I think that's fine. And then ultimately, we also want to, I suppose we want to be able to kill this entity, right? Because we did in our example, we basically went through all of these and said destroy. So instead, we're just going to yoink that. If I can, there we go. And put that there. Perfect. So now we have this kind of entity class, which we should hopefully be able to do everything we want to do. So why don't we make a new, let's make a new example called main better.cpp. And we're going to have the same thing. We have a main, and we're going to include the ECS controller. Cool. So let's make a bunch of entities. Controller, create entity. Entity. Cannot type. What's wrong with this? Let's just assume they're all okay for now. That's not a problem. 4, 5, 6. Perfect. So we've created a bunch of entities. Now what do we want to do? Let's register some components. Let's make some components. What are we going to do? We're going to make we're just going to make some kind of simple. Let's just make some kind of simple game components that you might see. Cool. So now we're going to auto gravity comp ID equals controller dot register component gravity component. Velocity comp ID transform comp ID. Let's now register our systems. So we're going to make, how many systems should we do? Let's do so let's call one like class physics system, and then class, oh, don't forget we need to inherit public system. And then we're going to do one called speed system, and that's just interested in things with velocity, for example. So register physics system first. Define physics system signature. So like we said, system itchy nose. Right, so system signature, physics sys sig equals physics sys sig set component. So now the physics system signature is interested in all of these components. So we're just going to register every single component. Velocity transform. Perfect. Now register physics system controller, register system, physics system physics sys sig, and then we don't have any args currently, but remember no discard sys physics sys d. So remember, we probably want these component IDs. So let's just make a constructor for that. Obviously, you don't have to do a probably a bit easier to make like some sort of macro or using for this, but velocity ID. Velocity component ID, transform. Public, private, and then let's just store change this component transform, and then construct it. The velocity transform. Okay, perfect. So now we have a system and we will construct it with this, and therefore we need to provide those IDs to this constructor here. Gravity, velocity transform, gravity, velocity transform. Perfect. And then we may as well just quickly whip up the old speed system. Constructor, velocity comp ID. Let's just presume it's like this, velocity comp. Get it from here. Okay, so now we've registered the physics system. Now let's do speed system. Sys sig. speed sys ID. Speed system. And then what's the speed system interested in? Only the velocity ID, right? Obviously, you could also just not make this a constructor and then like provide setters or make these public. Who cares? Like you might not care about that. Okay, so now hopefully this is easy. This is already looking easier, right? We create entity IDs, we register all the comments we compare about, and we then register all of our systems that we care about, and now register components with entities. And then hopefully all we have to do is, well, we shouldn't have to do anything else after that, because the entity wrapper should just tell all of the systems, inform all of the systems of the entity kind of component changes and update them. So let's say that this is going to have, entity 1 is going to have gravity, velocity, and transform, right? And gravity, and so is entity 2, velocity and transform. And entity 3 is just going to have gravity. Entity 4 is just going to have velocity. Entity 5 is just going to have transform. And entity 6 is going to have gravity and velocity, right? So we can effectively, we can already understand what's going to happen here. So the physics system, because it's interested in gravity, velocity, and transform, should see only these two entities. But the speed system that's only interested in velocity should see entity 1, 2, 4, and 6. So let's see if that works. And for now, we are going to go entity 1 dot add component ID. What do we care about? The gravity component ID. And then the component type, I'm just going to construct it there. Oh, it probably won't let us do R values. Yeah, expects an L value, that's fine. We can fix that later, but for now then let's just, we'll just make one generic gravity. And this is, yeah, again, we should be checking the errors, but I'm not doing that. So right now anyway. Oh, let's make a velocity component, generic velocity component. Sorry, I realized it was at the bottom of the screen. Transform component, generic transform component, generic transform component, generic velocity component. Switch these around. And that one compile, velocity comp ID, and transform comp ID. Okay, perfect. So we've done entity 1. Let's just do the same for 2, but I'm going to we know that 2 is correct, so let's do 3. What did 3 have? 3 had just gravity. So get rid of these. 4 had just velocity. 5 had just transform, I'm pretty sure. Transform, generic transform. And then 6 had gravity and velocity. Gravity, generic, gravity, and velocity. Like this. So now all of the entities have the components that we care about added. All we need to do is we need to write some like some update functions like this for const auto entity in entities. And this made me realize we should probably update this to entity, and we'll just, for now, we'll just forward declare this. Reason for that is because I want that entity, I want to be able to use that entity wrapper here so that we can kind of print that. And the other thing, we need to be able to show that we're actually doing the right thing. So let's add a like a get ID. Get ID. Return ID. So we can do entity, and then we'll do printf entity ID. It like that. Ah, okay. We need to mark this as const. And then we'll do the same for the speed system. Okay, and now all we need to do is get handles to systems. Controller dot get system physics. Call these physics sysid. So speed sys handle. Okay, now all we need to do is call update on that. Call update on speed. Let's just do some big printfs. Speed update. Let's just also add some things here. Okay, perfect. Why aren't you going to build? Update that. That would help, wouldn't it? Oh, now we have to fix all the errors. Bear with me. Of undefined entity. Okay, well, for now, let's just put this back to entity ID, and then what we'll do is we will call entity get, and then we can fix this later on by splitting the entity out into a different header file so that both System Manager and ECS Controller can share it. Get ID is not a member of ECS Controller. Where was that then? Yeah, that's fine. Ah, okay, it built. The surprise. Okay, so let's see what happens here. Oh dear. What have I done wrong? That is what I've done wrong. I registered the speed system with the physics system signature, not the speed system signature. So let's try again. Has that worked? So we can see here that the physics system was interested in gravity, velocity, and transform. And the speed system is just interested in velocity. So any components with velocity, it wants to know about. Any components, and the physics system, any components with all these three, it wants to know about. And as we can see, entity 0, which entity ID 0, which is entity ID 1 effectively, or entity 1 here, has all three, and these two are the only ones with all three, and the physics system has access to them. And then the speed update only cares about entity 1, 2, 4, and 6, which are effectively in ID 0, 1, 3, and 5, which is 0, 1, 3, and 5. And that is perfect. That's exactly what we wanted to do. So hopefully you can see that from the example. This is a lot nicer than the kind of previous way that we did things. We had to create entities, and then we had all of these kind of IDs floating around and the signatures floating around. Then we had to update each kind of system. We had to update the system manager every time there was a new entity. But now you just create an entity, you kind of add any sort of array of components that you want onto it, and then that component will be available in your physics update or your speed update or any system that you generate that has a corresponding signature. And just to show, what happens if we destroy one? Entity 4 has just velocity, so it should just disappear from the speed. So if we do another speed update afterwards, I'm stupid. So we took a copy of the system here, not a reference, and therefore we didn't actually get an updated reference of that system. So hopefully, again, perfect. So you can see here in the first physics and speed update, we get what we expected. After entity 4 is destroyed, the physics is untouched, but the speed update now has reflected that there isn't an entity anymore with that speed. And then just to make sure that everything is working fine, 3, 5, 6. We'll destroy all of them. And then print, and then just make sure that all the systems have no update. There we go. So now both systems have nothing. Perfect. So hopefully you've kind of seen how it's much nicer now, much more clean. Just create entities, register components, set components, register systems, and then add whatever components you need from this point onwards, and your systems will be updated effectively. Then you can destroy them, and again, they'll be created effectively. So there we have it. That's it. That is the ECS finished. Pretty much all of its functionality is there. There are obviously things that you can add, like niceties, helper functions, moving entities, like move semantics, all these types of things. But we have done the basics. We now have a controller where you can create entities, you can add, where you can register components, you can register systems, you can get systems out of it. Then when you create an entity, you get given an entity handle for this wrapper class that we've made. You can now add components to those entities, you can remove components from those entities, you can get components from those entities, and whenever we do the add and remove, the systems are already automatically updated, and you can see in the example app that we made that the systems, it just all works. Like, you don't have to do anything else. It's great. So I'm really happy. I hope you've learned something as well. In the next episode, we are going to do performance and optimization. So kind of looking at how it performs, seeing if there's any optimizations we can do. A couple of you have suggested some optimizations, which is great. And I really appreciate it. So I think we'll do a couple of benchmarks on that to see if we can gain anything. As always, thank you so much for watching. I really hope you enjoyed the video. Like, subscribe, comment, whatever you want to do. I appreciate it all. I enjoy reading your comments and the feedback. I'd love for you to come and watch the next video about the performance and optimization, but for now, I think that's everything. So I'm going to stop waffling. It's a long video, and I'll see you in the next one. Cheers.